Hari ini terakhir presentasi, betul ya?
Iya, Ma'am.
Let me check the attendance of today's presenters. Leni Marni ada?
Ada, Mem.
Oke, Zidan Fatih. Zidan ada?
Present, Ma'am.
Oke, Amelia Dwi.
Present, ma'am.
Keisha Putri.
Hadir, ma'am.
Oke, Chika Karisma.
Present, ma'am.
Oke, Syarifah Anastasia.
Hadir, Mem.
Syarifah ada. Pinata Anggraini.
Hadir, Mem.
Okay, so you're all ready for today's presentation. And who will be the moderator for today? Is it Gilang Ramadan? I've noted Gilang Ramadan as the moderator.
Iya.
Alright. Okay, so before we begin, kita berdoa dulu ya. Berdoa masing-masing dimulai. Oke, berdoa selesai. Ini yang belum hadir siapa nih? 35 orang. Rizky tadi absen terus ya tiap hari ya? Untuk absensi, Rizky?
Nanti saya akan absen, Bu, pada saat akhir-akhir. Soalnya kalau di awal-awal kadang-kadang masih ada yang belum masuk, Ma'am.
Oke, Ibu minta di absen 8:15. Karena memang toleransi kita 15 menit ya, Rizky ya.
Baik, Ma'am.
Tolong ya. Terus next week itu kan kita pertemuan tatap muka ya.
Iya, Ma'am.
Iya, jangan lupa dibawa absen form 0506-nya ya.
Baik, Ma'am.
Okay. Okay. We will begin today's presentation and I will give the presentation session to the moderator of today, Gilang Ramadan. Please, Gilang.
Okay, thank you, ma'am. Okay, Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. I hope you are all well. My name is Gilang Ramadan, and I'm thrilled to be your moderator for today's Zoom presentation. Okay, without further delay, let's start the presentation with our first speaker. Please join me in welcoming Leni Marni.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. My name is Leni Mani with student number 13056220001. On this occasion, I will explain about irrational number. Here, I will explain several things about irrational number, namely related to the definition, where we shall learn irrational number, characteristic of irrational number, example of calculation, the inventor of the irrational number, and continue with the calculation. So, definition of irrational number is a real number that cannot be expressed as a fraction, or its division result never terminates. In this case, an irrational number cannot be represented as a per b, with a and b as integer, and b not equals to 0. Irrational numbers are not rational numbers. Very popular example of irrational number include p, square root of 2, and the number e. Besides that, there are many other examples of irrational numbers such as square root of 3 and many more. Why we still learn irrational number? We need to learn irrational number because they are important part of the math and have many applications in everyday life and science, such as application in geometry, where irrational numbers are often used in measurement, such as the length of the diagonal and rectangles. In pure mathematics, studying irrational number is part of the development of mathematics and help us understand the nature and structure of numbers. There are several characteristics of irrational number. First, irrational numbers cannot be expressed as common fraction. This is because ordinary fractions are comparison of whole number, while irrational number have infinite digits behind their decimal point. The second is, when written as a decimal fraction, the fraction has infinite and not repeating decimals. For example, the square root of 2 has an infinite and not repeating decimal representation. In fraction notation, irrational number will have infinite number behind the decimal point and do not have a repeating pattern like regular fraction. Irrational number can be represented in square root form. There is the inventor of irrational number, Hipparchus of P14, which historically is dead because Pythagoras considered Hipparchus to be a heretic and result in his death sentence. After that, there is an example of calculating irrational numbers. 2 square root 3 times the square root 5 is equals to 2 times 3 multiplied by the square root of 3 times the square root of 5. An integer multiplied by an integer and a root number multiplied by a root number as well is equals to 6 square root 15. So, the conclusion of my material is irrational numbers are real numbers that cannot be expressed as ordinary fraction. They are also not part of the set of rational number. Popular examples of irrational number include p, square root of 2, and a. The key characteristic of irrational number is that when expressed as a decimal fraction, the expression is infinite and non-repeating, such as square root of 2 equals 1.4, 142, and so on. Furthermore, irrational numbers are often representable in the form of square root, like square root of 3, square root of 5, and so on. And here I have two references in completing this test. That is all I can explain. Wassalamualaikum warahmatullahi wabarakatuh. Bye-bye.
Okay, thank you, Lenny Marni, for that insightful presentation. Now, for our audience, we're going to open the floor for a Q&A session. If you have a question, please use the raise hand feature on Zoom. Once your hand is raised, please turn on your microphone and feel free to share your question. Okay, dari Aldona.
Okay, thank you for the opportunity, Gilang, and thank you for the good presentation on me. But I want to ask you some question. The question is, what do the statements repeating decimal expression and non-repeating decimal expression mean? And can you give an example for each? Is it clear, Lenny?
Clear, Aldona. Okay, give me some time to answer and maybe we can move on to the next question.
Okay, thank you, Lenny, for very good and interesting presentations. But I still have a questions from your posters. And the question is, can you give an example in daily life where we can relate the use of irrational numbers? Okay, thank you, Lenny.
Okay. I will answer question from Agana. The question, what do the statement repeating decimal expression and not repeating decimal expression mean? Give an example for it. A repeating decimal expression refers to a situation where the decimal part of a number has a pattern that keeps repeating. For example, consider the fraction 1/3. It is decimal representation. The result is 0.33333 with the digit 3 repeating endlessly. Meanwhile, a not repeating decimal expression occurs when the decimal part of a number does not have a continuously repeating and endless pattern. Irrational number like square root of 2 have not repeating and not ending decimal expression. A square root of 2 has a decimal expression that does not repeat and does not end. And there is an identifiable pattern that keep repeating. Is it clear, Aldona?
It's clear for me. Thank you.
Okay, I will answer the second question from Rizky. The question, find examples in daily life where we can relate the use of irrational number. Example of everyday life include the measurement of diagonal length in rectangular or triangular objects, as well as architectural design that may involve irrational numbers such as square root of 2 and p. Is it clear, Rizky?
Okay, it's very clear, Lenny. Thank you.
Okay.
Okay, because we have already gone through the Q&A session, now let's move on to our next presentation. Thank you, Lenny Barni. Please welcome Amelia Dwi. I'm sorry, I mean Zidan Fatih. Sorry. Please welcome Zidan Fatih.
Hello everybody, my name is Zidan Fatih Hazami Hakim, and in this video I am going to explain to you guys about linear equations. Linear equations are not just essential in mathematics, but also have real-world applications that impact our daily lives. In this video, we will break down what linear equations are, how to solve them, and why they matter. We will dive deep into the world of linear equations, unraveling their significance and demonstrating their practical applications. Hope you guys enjoy the video. At its core, linear equations is a mathematical expression that represents a straight line when graphed. It's typically written in the form ax plus b equals 0, where x is the variable, a and b are constants, and a is not equal to 0. When we graph a linear equation, we get a straight line. This line has a slope, which represents the rate of change, and a y-intercept, which tells us where the line intersects the y-axis. Understanding these elements is crucial in interpreting the equation. Now, let's dive into why linear equations matter. They are used in various fields, such as economics, physics, engineering, and more. For instance, in economics, linear equations can model supply and demand curves, helping businesses make informed decisions. Let's illustrate the practical use of linear equations with an example. Imagine you are planning a road trip. You want to calculate your total expenses, which include gas, food, and accommodation. By using linear equations, you can create a budget model, allowing you to make informed decisions about your expenses. Solving linear equations is a fundamental skill. To solve for x in the equation ax plus b equal to 0, you can use basic algebraic operations to isolate x on one side. The solution for x equals to minus b over a. Linear equation has many forms, such as slope-intercept form, which written y equals mx plus b, where m is the slope, and point-slope form, which written y minus y sub 1 equals m times x minus x sub 1. We can use this point-slope form if we know the slope at any point in the line. These forms provide different insights and may be more suitable in various scenarios. Linear equations become even more powerful when used in systems. Systems in linear equations involve multiple equations with multiple variables. Solving them helps us find solutions to complex real-world problems. In conclusion, linear equations are the building blocks of mathematics with wide-ranging applications. They are not just abstract concepts, but practical tools that empower us to make informed decisions and solve problems in our everyday lives. Maybe that is enough to tell you guys how important and useful linear equations in real life are. I hope this video helps you guys understand it. Assalamualaikum warahmatullahi wabarakatuh.
Okay, thank you Zid and Fatih for the enlightening presentation. Now, for our virtual audience, if you have questions, please use the raise hand feature on Zoom. Once your hand is raised, please turn on your microphone and feel free to share your question. Okay, Najwa Baskara, please share your question, please.
Okay, thank you for the opportunity and thank you Zidan for your presentation. That's a really good presentation, but I still have a question for you. My question is, in the context of a linear equation, what does the slope represent and how does it influence the graph? Is it clear, Zidan?
Clear, Najwa. Thank you.
Could you please open your camera, students? Terutama yang bertanya nih tadi.
Okay, thank you, Zidan, for your presentation. I want to ask, why do we need slope when it comes to linear equation? Is it clear, Zidan?
Yes, very clear, Salsa. Thank you. Okay, since there are two people asking, let me answer the question. First question is from Najwa. The question is, in the context of a linear equation, what does the slope represent and how does it influence the graph? The answer is the slope of a linear equation represents the rate of change or the steepness of the line. It indicates how much the dependent variable changes for a 1 unit increase in the independent variable. A positive slope indicates an upward trend, while a negative slope signifies a downward trend. The steeper the slope and the faster the change. Is it clear, Najwa?
It's clear, Zidan. Thank you for the answer.
Okay, and next question is from Salsa. Why do we need slope when it comes to linear equation? The answer is the slope in a linear equation is actually very crucial because it provides essential information about the relationship between variables. Understanding the slope allows us to interpret and analyze the behavior of variables within the linear equation, making it a valuable tool for modeling and solving real-world problems. Sorry. Is it clear, Salsa?
Okay, it's clear. Thank you, Zidan, for your answer.
Okay, thank you.
Okay, thank you, Zidan. Because we have already gone through the Q&A session together. Now, let's move on to our next presenter. Please welcome Amelia Dwi.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Amelia Dwi Juliani from Mathematics A 2020. Here, I will explain the result of the poster I have made. I made a poster with the title Get to Know Mathematical Induction. First of all, I would like to express my thanks to Ma'am Dr. Puspita Sari SPD MSc as a lecturer in English Mathematics course and friends who have participated in preparing my presentation video today. The first, what is mathematical induction? The definition of mathematical induction is a mathematical technique used to prove statements about positive integers, or mathematical induction is a proof technique used to establish the truth of an infinite number of statements. Next, the principle of mathematical induction. At its core, mathematical induction consists of two steps, the base case and the induction step. The basic principle of mathematical induction are: first, basic step or base case. The base case is the first step where we prove that a statement is true for a specific value in the set of numbers we're interested in. Prove the statement for n equals 1. Next, induction step. The induction step is where we assume the statement is true for value n equals k, and then prove that the statement also true for n equals k plus 1. Now, we're going to go over some examples associated with mathematical induction. So let's say if we have statement 1 plus 2 plus 3 plus all the way up to n is equal to n times n plus 1 divided by 2. So, we want to check the base case. We're checking most simple basic case that we can come up with here, and it's going to be when n equals 1. And we're just going to check that for n equals 1 on the left hand side and the right hand side is true. So, the first term happens to have the value 1. 1 times 1 plus 1 divided by 2, and then we're just simply checking to see if the right hand side is equal to the left hand side. For this base case, 1 plus 1 is 2. We'll multiply that by the 1 on the left here, divide that by the 2 on the bottom. 1 times 2 is 2 divided by the 2 on the bottom is simply equal to 1. So, for the base case, for n equals 1, we have basically 1 on the left hand side equals 1 on the right hand side. Basically, for the basis case, we have 1 equals 1 and that is a true statement. Now, we're going to show that it's true for n equals k plus 1. We have 1 plus 2 plus 3 plus all the way up to k, and then we go one more further to k plus 1, and then we're going also to plug in k plus 1 where the n's are here. So, this is going to be k plus 1 for that part, and that's multiplied by k plus 1 plugging that in where the n. And then we have a plus 1, we could put this in parentheses to kind of offset it apart, but really we're just going to be adding this anyway. Then we simplify it so that we can see the results on the poster, namely k squared plus 3k plus 2 from the left hand side or right hand side is the same. So the results are proven. Therefore, we assume that this is true. So the next step is going to be the induction step. We're just going to assume that this statement is true for some value n equals k. So we're going to assume that, let's say we have 1 plus 2 plus 3 plus all the way up to some value k. We're just going to assume that's equals to the right hand side. So plugging in k where n's our k plus 1 divided by 2. So we have assumed that this is true. In conclusion, the method of mathematical induction is a very powerful tool in mathematics. With this approach, we can solve many problems in various areas of mathematics. It's important to understand the basic principles and proper steps when using the mathematical induction method. Hopefully, this poster has provided a better insight into how to apply this method in solving mathematical problems. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Amel, for that informative presentation. Now, for our virtual audience, if you have a question, please use the raise hand feature on Zoom. Once your hand is raised, please turn on your microphone and feel free to share your question. Okay, we get first Vinata Anggreni, please share your question.
Thank you, Amel, for the presentation. I want to ask, why is it important to have basic steps in the mathematical induction method? Is it clear?
Is it clear, Vinata?
Okay, next for the second, Stephen G.
Okay, thank you. Thank you, Amel, for the presentation, but I have a question. When do we use mathematical induction to solve mathematical problems? Is that clear?
Is it clear, Stephen? Okay, I will answer the question from Vinata and Stephen. The first question from Vinata, the question is, why is it important to have basic steps in the mathematical induction? In the mathematical induction method, is it true, Vinata?
Yes.
Okay, the basic step in mathematical induction is important because it confirms that the statement you want to prove is true for certain initial values. This provides the basis for starting the induction process, ensuring the validity of the evidence for all relevant association members. Has the question been answered, Vinata?
Thank you.
The next question from Stephen. The question is, when do we use mathematical induction to solve mathematical problems? Is it true, Stephen?
Yes.
Mathematical induction is often used when we want to prove a statement for every positive integer or every non-negative integer. This is useful for investigating traits that appear rapidly or gradually. Has the question been answered, Stephen?
Yes, it is.
Thank you to the moderator Esa Gilang and friends who asked. I will return it to the moderator.
Okay, thank you, Amel, because we have already gone through the Q&A session together. Now let's move on to our next presenter, Please welcome Keisha Putri.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Keisha Putri Zali Kalmar with student number 13056222018 from Mathematics major. On this occasion, I will explain my poster about absolute value. Definition. The absolute value or modulus, the absolute value of x of a real number x is the non-negative value of x without regard to its sign. The absolute value of a number may be thought of as its distance from zero along real number line. Furthermore, the absolute value of the difference of two real numbers is the distance between them. If x is a real number, then the absolute value of x is equal to x if x greater than or equal to 0, minus x if x less than 0. Properties of absolute value. 1. The absolute value of a greater than or equal to 0. 2. The absolute value of a is equal to 0 is equivalent to a is equal to 0. 3. The absolute value of ab is equal to the absolute value of a times the absolute value of b. 4. The absolute value of a plus b less than or equal to the absolute value of a plus the absolute value of b. 5. That the norm of x is equal to the absolute value of a. 6. The absolute value of minus a is equal to the absolute value of a. 7. The absolute value of a minus b is equal to 0 is equivalent to a is equal to b. 8. The absolute value of a minus b less than or equal to the absolute value of a minus c plus the absolute value of c minus b. 9. The absolute value of a per b is equal to the absolute value of a per the absolute value of b if b is not equal to 0. How to solve an absolute value equation? First thing first, separate the absolute value expression from the rest of the expression. To solve the expression in absolute value notation so that it can be expressed as a positive or negative quantity. 3. Find a solution for the unknown. 4. Double check your work by graphing it or inserting the answers into the equation. Example. Solve and graph the answer. The absolute value of x minus 1 greater than 2. Notice that the absolute value expression is already isolated. Compare the contents of the absolute value portion to both 2 and minus 2. Be sure to reverse the direction of the inequality when comparing it with minus 2. Solve for x. Added both sides by 1, so 2 plus 1 is 3. Therefore, x is greater than 3. Next example, we need added both sides by 1. Negative 2 plus 1 is negative 1, so x is less than negative 1. At this point, we can graph the solution on a number line. Now, x is greater than 3. Since it's greater but not equal to, we need an open circle. And because it is greater than, we need to shade to the right side. Now, the other answer is x is less than negative 1, so we get a shade to the left side all the way To the left is negative infinity and to the right positive infinity. So the answer in interval notation is negative infinity to negative 1 union 3 to infinity. Okay, the application of absolute value. The absolute value function is used in many real-life applications to represent the distance between 2 points on a number line. For example, in physics, the absolute value of the displacement of an object is used to indicate how far the object has moved from its original position. In finance, the absolute value of the difference between two currency exchange rates is used to indicate the potential profit or loss in a foreign exchange transaction. In engineering, the absolute value of the difference between a measured value and a desired value is used to indicate the accuracy of measurement. Conclusion. A number's absolute value is its distance from zero. Absolute value can also be thought of as the size of a number without taking into account its sign. Model problems with a vertical or horizontal number line to help you understand the absolute value. The difference between 0 and the absolute value of the difference between numbers will be clear with the help of the number line. Absolute value is represented by a vertical line on either side of the amount, whether it is a number or a variable. So that's all the material about absolute value. Hopefully you can understand. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh. Wassalamualaikum warahmatullahi
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Keisha, for that insightful presentation. Now, for our virtual audience, for the Q&A session, if you have a question, please use the raise hand feature on Zoom. Once your hand is raised, please turn on your microphone and feel free to share your question. Okay, for the first questioner, please Ulan share your question.
Okay, thank you for the opportunity. First, thank you, Keisha, for the presentation. The presentation are very good. But I have a question for you. The question is, what is important about absolute value? Is clear, Keisha?
Yes, it's clear, Ulwan.
Okay, thank you, Keisha.
Okay, I will ask for the second question. Thank you, Keisha, for the presentation. But I have a question. The question is, how many solutions does the absolute value have?
Okay. Okay, I will answer the question from Ulwan and Gilang. The first question is, what is important about absolute value? The absolute value of a number represents its distance from zero on a number line, always resulting in a positive value. This concept is essential in mathematics, as it helps to simplify calculations and understand the magnitude of numbers, regardless of their positive or negative sign. For second question, how many solutions does the absolute value have? The absolute value have three solutions. If an absolute value is being compared to a positive number, then there will be two solutions. If an absolute value is compared to zero, then there will be only one solution. If an absolute value is less than or equal to a negative number, then there will be no solution. Is it clear, Gilang and Uwan?
Is it clear? Thank you, Keisha.
Clear. Thank you, Keisha.
Okay.
Okay, thank you. Okay, thank you, Keisha, for the presentation. Because we have already gone through the Q&A session together, now let's move on to our next presenter. Please welcome Chika Karisma.
Hello everyone, my name is Chika Karisma Ferdian, usually called Chika, with student registration number ending in 055. I want to explain the matter regarding logarithms equation that we studied in high school previously. And before I explain what logarithms are you curious about who invented logarithms? Okay, I will tell you. Introducing, his name is John Napier. John Napier is best known as the inventor of logarithms. Logarithms were introduced by John Napier in 1614 as a tool to simplify calculations. First, let's find out what logarithms are. Logarithm is an inversion operation or the opposite of exponentiation.
But is finding the power value from a number relatively easy? For example, what is the result of 2 to the power of x equals 8? The answer is definitely 3, right? Why bother learning logarithms?
If from that, it is easy to answer because the cardinal number and the logarithm value are both the whole number. But what if one of them is decimal? For example, 5 to the power of x equals 2236. What is the value of x? You must be confused, right? Therefore, logarithms help us to find the answer. Now, you understand why do you have to study logarithms material? Okay, let's continue. Once you know what logarithm is, you also need to know that it has a general form. What is the general form of a logarithm? Let's take a look at the following picture. How? Starting to understand, right? Well, usually you will often be confused about determining which number is base and which number is the merest, isn't it? Calm down, guys. The key is you just remember the cardinal number is a base, located at the top before the log sign, and the number resulting from the power is numerous, located at the bottom after the word clock. It is easy, right? Logarithms also have properties that you must understand. Why is it mandatory? Because this characteristic will equip you to work on logarithms problem. Without understanding the properties of logarithms, you will not be able to do logarithms problem. So, what are the properties of logarithms and what are some explains? Come on, let's look at the picture below. Okay, so that you understand the properties of logarithms above to use the model equation like this? Let's try to do the question below. We'll do it together, okay? In the problem beside, the first thing we have to do is check the base. The two logarithm equations above apparently have the same base value, namely 2. So, because the base is the same, we can use the second property of the logarithm to find out the result. So, the logarithm of 4 base 2 plus the logarithm of 8 base 2 equals the logarithm of 4 times 8 base 2 equals the logarithm of 32 base 2 equals 5. Remember, the purpose of logarithms is to find powers. Let x represent 2 powers. So, what is the 2 to the power of x equals 32? The answer is 5. Very easy, right? After you understand the example question above, what do you think? It turns out that logarithms are not difficult material to understand. Now, don't forget to always remember this. Even though logarithms seem difficult and complicated, it turns out that they can be applied in everyday life. For example, like this. So, in the essence, by studying logarithms, we can find the value of power from cardinal number whose the result by power is known. Okay, that's all my brief explanation about logarithms. See you next time. Dadah!
Okay, thank you, Chika, for that enlightening presentation. Now, for our virtual audience, if you have a question, please use the raise hand feature on Zoom. Once your hand is raised, please turn on your microphone and feel free to share your question. Okay, for the first question, or Zidan Hakim, please share your question.
Hello Chika, good presentation by the way. I'm still have to ask you, what is the difference between logarithms and algorithms? Thank you.
Okay, for the next question, Vinata.
Okay. Thank you, Chika, for the presentation. I want to ask, are logarithms always positive numbers?
Yeah, I will answer. First, thank you for the question, Zidan. The answer is an algorithm is a series of procedures that can be used to solve a particular problem, while logarithms are exponentiation. Okay, maybe that's all answer for me. Is it clear, Zidan?
It's very clear, thank you.
Okay. For Vinata, thanks for the question. I will answer from a question from Vinata. The answer is yes, because the graph of the logarithm function in Cartesian coordinates never cuts the y-axis. This means that the x value on the logarithm function graph will always be positive. Is it clear, Vinata?
Clear, Chika. Thank you.
Okay, because we have already gone through the Q&A session together, now let's move on to our next presenter. Please welcome Sharifa Anastasia Putri.
Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. My name is Sharifa Anastasia Putri with name ending in 49. Today I will be discussing the intriguing relationship between fractions, time measurement, and calendars. Time measurement and date determination in calendars are integral aspects of our daily lives But have you ever thought about how fractions play a crucial role in enhancing precision and accuracy in this context? Fractions are vital in ensuring precision and accuracy in measuring time and determining dates in calendars. This understanding is essential for optimizing planning.
Maybe someone could help Anastasia to play the video, to share the video. Okay.
Assalamualaikum warahmatullahi wabarakatuh. Good day, ladies and gentlemen. My name is Sharifa Anastasia Putri with name ending in 49. Today I will be discussing the intriguing relationship between fractions, time measurement, and calendars. Time measurement and date determination in calendars are integral aspects of our daily lives, but have you ever thought about how fractions play a crucial role in enhancing precision and accuracy in this context? Fractions are vital in ensuring precision and accuracy in measuring time and determining dates in calendars. This understanding is essential for optimizing planning, improving efficiency, and making informed decisions. The knowledge of the relationship between fractions, time, and calendars enriches education and research in timekeeping and precision, bridging the gap between precision and convenience. Let's dive into how fractions are used in time measurement. An exemplary case is the Babylonian culture, which divided 1 hour into 60 smaller parts using the fractions 1 per 60, which we now call minutes. In their development, they even used 1 per 60th fractions of these minutes to form even smaller time units known as seconds. This precision allows us to plan our daily activities with remarkable accuracy. Fractions were not limited to time units. Babylonians also used fractions in their calendar system. They divided the year into fractions like 1 per 12, representing the number of months in 1 year. This division helped them align their calendar with the movements of the moon and the sun, impacting agricultural planning and religious celebrations. Now let's compare calendar system with fractions to those without. Calendar system with fractions allow for finer adjustment in measuring time, accommodating differences between solar years and lunar cycles. On the other hand, calendar systems without fractions are simpler, suitable for everyday use, and practical for quick decisions making. The use of fraction in calendar system strikes a balance between time accuracy and practicality, while system without fractions lean more towards simplicity and convenience in daily life. Applying fractions in time measurement and calendars has several important implications. Using fractions in time units breaks time into smaller units such as minutes and seconds, resulting in improved time precision, efficient scheduling, and minimal delays. Fractions used in calendars, including leap days and fractional day adjustment, contributes to calendar regularity, ensuring calendars correlate better with astronomical events. Fractions used in calendar system and timekeeping varies across cultures, reflecting cultural diversity and individual identities. Emphasizing education about fractions in the context of time and calendars prepares individuals to face the complexities of modern time measurement. In conclusion, Understanding the use of the fractions in time measurement and calendars is crucial for precision, efficiency, and cultural diversity. It enhances our time management, decision making, and ability to adapt to diverse cultures.
Okay, thank you, Sharifa, for that informative presentation. Now, for our virtual audience, if you have a question, please use the raise hand feature on Zoom. Once your hand is raised, please turn on your microphone and feel free to share your question. Okay, we get the first questioner, Amelia Dwi Juliani. Please share your question.
Okay, first of all, your video is very interesting, Sharifah. I have one question for you. How can the concept of using fraction as applied by the Babylonian culture in the division of time provide inspiration for innovations in time management and calendar technology today? And how can this historical understanding form the basis for the development of new solutions? Is it clear, Sharifah?
Can you write down on the chat Zoom, please?
Okay.
Okay, for the next question, Muhammad Yusuf, please.
Thank you for the opportunity. As students discuss the relationship between fractions, time measurement, and calendars, how can these concepts be innovatively integrated in modern technology to improve the way we manage time and plan our daily activities?
Can you write down on the chat Zoom, please? Okay. Thank you for asking, Amel. The question from Amel is, how can the concept of using fraction as applied by the Babylonian culture in the division of time provide inspiration for innovative in time management and calendar technology today? And how can this historical understanding form the basis for the development of new solutions? The Babylonians were pioneers in using fractions to divide time into smaller units, such as minutes and seconds. This was a remarkable achievement that laid the groundwork for future innovations in time management and calendar technology. By studying how they use fractions, we can gain insights into how to design intelligent algorithms for modern applications or software that can optimize time, allocation, and scheduling. One possible innovation is to develop algorithms that can dynamically adjust time segments according to the changing needs and preferences of an individual. For instance, the system could use fractions to suggest time slots that match the optimal energy levels or activity choices at any given time. Therefore, learning from the ancient use of fraction in Babylonian culture can inspire us to create more innovative solutions for time management, blending historical wisdom with technological progress to create smarter solutions relevant to modern life. Is it clear, Amel?
Is it clear, Sharifah? Thank you.
Okay, thank you. The next question from Yusuf. The question is, as students discuss the relationship between fraction, time measurement, and calendars, how can this concept be innovatively integrated in modern technology to improve the way that we manage time and plan our daily activities? I think how amazing is it that we can use fraction to measure time in different ways. Fractions are not only useful for math, but also for creating smart apps that can help us manage our time better. These apps can calculate how long it takes to do something, give us tips on how to schedule our tasks, and even adjust to the different ways that people use calendars based on their culture. For example, some people follow the solar year, while others follow the lunar cycles. Technology can make our lives easier and more enjoyable by respecting our diversity and preferences in time management. Is it clear, Yusuf?
Very clear. Thank you very much.
Hand it back to Gilang. Thank you.
Thank you, Sharifa. Okay, because we have already gone through the Q&A session together, now let's move on to our last presenter. Please welcome Vinata Anggraini.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, I'm Vinata Anggraini with student ID number 13056222069, and I'm here to present my poster about P number. So yeah, let's start. What is P? P, also called P, is an irrational number which is obtained from the ratio or comparison between the circumference of a circle and the diameter. The first 30 decimal place of the number P are, you can read this yourself. And here's an illustration of P when there's a circle with a diameter. This illustration is a circle with diameter or D and circumference or C. P is the ratio of dividing C by D, or in other words, P equals C divided by D. The value of P is always constant, which means that the value of P doesn't depend on the size of circle. And next we have history of P. The earliest recording of P is about 1900 to 1680 before century, when the ancient Babylonians calculate the area of a circle by taking 3 times the square of its radius, which gives a value of P equals 3. One Babylonian tablet indicates a value of 3.125 for P, which is closer approximation. Then the first calculation of P was done by Archimedes of Syracuse around 287 to 212 before century. He is one of the greatest mathematicians of the ancient world. Archimedes approximated the area of a circle by using the Pythagorean theorem to find the area of 2 regular polygons. The polygon is described within the circle and the polygon within which the circle was circumscribed. In this way, Archimedes showed that the P is between 3/1/7 and 3/10/71. And last, there's a Chinese mathematician and astronomer Zhu Chongzhi, who lived from 429 to 501. He calculated the value of the ratio of the circumference of a circle to its diameter to be 355 per 113 by using Liu's algorithm and implementing it using 12,288 code. Mathematicians began using the Greek letter to symbol P in the 1700s, introduced by William Jones in 1706. The letter itself is the first letter of Greek words periphery and perimeter. After history of P, there is also application of P. P is used in many areas of mathematics, science, and engineering, including trigonometry, geometry, calculus, and physics. P is also important in computer science, where it's used in algorithms for numerical analysis, machine learning, and cryptography. The application of P in nature can measure things like ocean wave, lake wave, sound wave, river bands, and radioactive particle distribution. So, in conclusion, P is a fundamental notion that applies in all areas of mathematics. It is a vital principle that aids in the comprehension of universal truths as well as certain mathematical topics. That's my presentation about P number. Thank you for listening, and I'm sorry of any mistake I made when presenting my poster. If you have a question about the poster, feel free to ask. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Vinata, for that insightful presentation. Now, for the virtual audience, we're going to open the floor for a Q&A session. If you have a question, please use the raise hand feature on Zoom. Once your hand is raised, please turn on your microphone and feel free to share your question. Okay, Zidan, please share your question.
I want to ask about what is Liu's algorithm? What is Liu's algorithm? Is it clear, Minata?
Okay, it's clear. Maybe I will answer Zidan's question first. So Liu's algorithm is an algorithm for the approximation of P. Liu utilizes the method of inscribing a polygon within a circle to approximate P to equals 157 divided by 50 on the basis of a 192-sided polygon. This method was similar to the one employed by Archimedes, whereby one calculates the length of the perimeter of the inscribed polygon utilizing the properties of right angle triangles formed by each half segments. Liu subsequently utilized a 3072-side polygon to approximate P to equal 3.14159, which is more accurate approximation than the one calculated by Archimedes. Is that clear, Zidan?
Clear, Vinata. Thank you.
Bye.
Okay, for the next question. Okay, Auday.
I wanna ask for Vinata. Is P never repeating? Thank you.
Okay. So decimal P is an infinite decimal that doesn't repeat. This means that there is no pattern to the digit that follows the decimal point. The digits of P have been calculated to trillions of decimal places, and there is no evidence of pattern emerging. Is it clear, Audrey?
Clear, Vinata. Thank you.
Hi.
Okay, thank you, Vinata, for the presentation. Okay, As all presenters have concluded their presentation, we shall bring today's Zoom presentation to a close. Sincere gratitude to our distinguished presenters, the attentive audience, and a special acknowledgement to Ms. Puspitasari, our esteemed lecturer, for her invaluable guidance. Should there be any further inquiries or discussion, please don't hesitate to reach out. Thank you to everyone for contributing to the success of today's Zoom presentation. Until we meet again, stay inspired and have a wonderful day. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Gilang, for moderating today's presentation. And let's give a big applause to all of us because all the 35 students have conducted your presentation. Tidak ada yang terlewat ya?
Ya, aman, ma'am.
Yes, okay. So everyone has presented their topic and presenting their poster presentation and also conducting the discussion. So I will give a short review of your performance from the beginning of the presentation. So basically what you've been doing from the week 12, I think 12 or 11. So before you begin the presentation, of course, you need to prepare the topic for your presentation, right? So first you need to choose the topic and then prepare the media for the presentation, which is the poster presentation, and then conduct the presentation and also answer the questions from the audience. So I hope that you've learned a lot this practice, preparing for a poster presentation and also answering questions from the audience. I also want to give a big appreciation to our moderators, which are, I think we have 4. Is it correct? We have Muhammad Rizky Firmansyah, Ananda Fitri Rahmawati. Can I see where is Ananda? And Muhammad Rizky Rahman Hakim, also Gilang Ramadan. Is it correct? For
Yes, ma'am.
of you? Okay, so I didn't miss any one of you yang jadi moderator ya. Can I see Ananda? Where is Ananda?
Wait, ma'am.
All right. So thank you so much for the students who were voluntary being the moderator for our discussions. So I will share you my slide because in my slide there is a rubric for scoring for your presentation. Wait a minute. All right, can you see it? Can you see the rubric?
Yes, ma'am.
Right. So basically, although previously I have shown you a rubric for these poster presentations, but practically I only use this 5, 1, 2, 3, 4, 5 aspects to give score of your performance. So the first one is motivation. Did you give the motivation of why you are choosing the topic in your presentation? Ada nggak informasi ke audience kalau this topic is important because blah blah blah. When it's absent, of course, you cannot get the full point from this first score motivation. And I see that many of you has skipped this part. Banyak yang skip the motivation part of your presentation. Although I've told you before that you need to give an introduction of your topic. And one of the introduction part is giving your motivation. Ingat nggak Ibu pernah bilang di kelas? Di bagian introduction harus ada penjelasan kenapa ini penting. Gitu. Do you still remember that? So it counts for 20% for the whole score. And then the second one is the content. And the third one is still the content. Tapi di bagian kedua, I focus on the poster and the video. And the third one is the new perspective of the concept. It's part of the content. So one example of the new perspective of the concept is when I think one of you, is it Anastasia or I forgot, the one who presented about fractions and time measurement. Is it correct, Anastasia?
Yes, ma'am.
So Anastasia has given an example how to give a new perspective of the fraction concept, because she integrated the concept of fractions, the concept of Babylonian number, and the concept of time measurement. So that's one example of how you give a new perspective of the concept. If you only present a single topic, a single mathematics topic, without relating it to another concept or context, then I could not consider it as a new perspective. But you still get a point. Ya, tetap ada poinnya, tapi tidak maksimum gitu. And then the delivery, the fourth aspect is delivery, how you pronounce the mathematical expressions. Karena ini bagian dari yang kita pelajari, benar nggak? And the last one is answering questions. Although I've noted that most of you have prepared the answers, I think most of you have prepared the answers prior to the presentations. I could understand, it's okay. I still give you points for answering questions. But at some point, I see there are differences in terms of the quality of the questions. Ibu bisa lihat mana yang memberikan pertanyaan hanya sekedar memberikan pertanyaan, ada yang memberikan pertanyaan yang berkualitas. Jadi itu Ibu bisa bedakan ya. And I have noted some names who have given qualified questions to the audience. Gitu ya. So, I think I also from today's performance tadi the last presenter, mungkin karena ini the last presenter ya, jadi Ibu tadi sempat notice Hinata, isn't it? Kalau nggak salah, tadi kamu sempat bilang you can read it by yourself gitu di video presentation. Did you all notice that?
Yes, ma'am.
Yes, please don't do that again in your presentation. Vinata, where is Vinata? Itu Vinata bukan yang terakhir tadi?
Yes, ma'am.
Yes. So thankfully, it's still a practice. I mean, in the classroom, it is always a practice. But in the reality, when you have to give your own presentation, don't do that again. Okay? Don't say that you can read by yourself. You have to give an interesting information about your topic. Jadi jangan suruh audiens
Okay, ma'am.
when you want to pose questions, many of you say like this, your topic is interesting, but I still have questions. Kira-kira kedengarannya gimana tuh? Your topic is interesting. Your video presentation is wonderful, but I still have questions. Gitu. Kira-kira gimana kedengarannya? Karena Ibu sering dengar beberapa kali, jadi kayaknya ini perlu diperbaiki nih gitu. Ada yang punya komentar? Gilang, gimana Gilang menurut kamu?
Kalau menurut saya yang bagian awal itu dari apresiasi dulu, Bu. Jadi apresiasi kepada presenter karena sudah memberikan presentasi terbaiknya. Setelah itu baru kita mungkin karena masih ada yang bingung, baru bertanya seperti itu, Mem.
Yeah, but kata but-nya itu loh muncul. Jadi biasanya kalau kamu mau tanya itu kan kalau di real situation ya, di real situation kalau audience mau menanyakan sesuatu ke presenter itu artinya dia benar-benar curiosity-nya tinggi, pengen tahu lebih dalam. Tadi sebetulnya teman-teman kalian semua udah menyatakan apresiasi di awal. Your topic is interesting and so on and so on. Tapi kata but-nya itu sebaiknya di skip aja, jangan dipakai. Mungkin kamu bisa kasih kalimat such as I would like to know more about blah blah blah. I'm interested in understanding about your topic. For example, this and this and this gitu. Jadi ketika nadanya itu kesannya kayak but itu kesannya kayak ya apa namanya kesan ketertarikan seorang penanya kepada presenter itu jadi kurang gitu ya. Jadi biasanya kalau kamu mau bertanya itu memang kamu tertarik ingin tahu lebih lanjut tentang apa yang dipresentasikan oleh si presenter gitu. Yeah, I think that's all my notes for your presentations and also how to become a moderator. Kita telah lihat contoh dari Muhammad Rizky 1, Muhammad Rizky 2, dari Ananda dan dari Gilang, how they act as a moderator. Jadi the function of a moderator is of course to facilitate the presenter and the discussions, all right, and to managing the flow of the presentation. So sometimes when in the future you have to act as a moderator, you know how to perform as a good moderator. Okay, so do you have any questions? Maybe about the rubric for the scoring or for anything else? Any questions from you? Maybe from Rafli, where is Rafli? Andita Bina, ini kenapa ditutup semua kameranya nih? Iksan Agustianto. Oke. Stephen DJ. So for next week, we will meet face-to-face. We will discuss the last topic of our course. We're still continuing about the graph, yeah, how to interpret graph. And based on our academic calendar, I think we should have had our final exam in the second week of December, but I'm not sure if it's still applied. So let's see next week about the further information for the final exam. Mungkin bisa di pekan kedua, but bisa juga mundur seminggu gitu ya. Okay, any questions from all of you before we end today's session? Nope. All clear? Okay. Thank you thank you very much for your attention, and I'll see you next week. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.